Alright, today's lesson is about compound inequalities. Specifically, we are going to be talking about and or statements. Now, yesterday or the day before, we worked on just solving inequality equations or inequalities in one variable. So it's like, hey, x plus 2 is greater than 4, and we just had to solve that little inequality just like we solve equations, except for when we divide or multiply by a negative. We found out in this case x is greater than 2, and we could graph that. And so our graph looks something like that, and so our final solution was all that information. Today's is exactly the same thing with one exception, and it centers around these two words and an or statement. So I have a couple of slides here that kind of illustrate those without numbers, and then we'll talk about it with numbers. So here I've got two different statements, and we're going to focus on the first one here. Okay, we'll look at this and statement. And it says circle the shirts that are red and long sleeve. So if you look over here at the right where I've got several shirts shown, I want the ones that are red and long sleeve. And means they have to satisfy both. And there is only one shirt that actually satisfies both those conditions. While this shirt is red, it is not long sleeve. And the and statements require that you satisfy both of those statements. Let's look at the next statement. In this case, circle shirts that are gray and short sleeve. So I want shirts that are gray. So we had gray and a gray, but they also have to be short sleeve, and so in this case, it is those two shirts. So and statements mean you must satisfy both conditions. Let's look at the other type of statement we're dealing with, the or statement. And we want to circle shirts that are, let's get our highlighter right here, that are red or long sleeve. So as we look here, we've got a red shirt. Okay. Here we have a red shirt and it's long sleeve. And here we have a shirt that's just long sleeve. In this case, you don't have to be red to get circled, because you could just be red, which would satisfy the first part, or you could be long sleeve, which satisfies the second part. So in this case, we have three shirts that actually satisfy those statements because it's an or. And now let's look at our last or statement, or the second or statement here. In this case, gray or short sleeve. And so we can circle anybody who's gray, and we can circle anybody who is short sleeve. So we can see we get a lot more shirts in this case because it is an or statement. Again, you only have to make sure one of those is true to be in the final selection. Let's look at how this affects us with numbers now. Here I've got an and statement. I want all the x's that are bigger than 2. So all numbers bigger than 2, and at the same time they have to be less than 10. So you have to satisfy both those. Now the easiest way to illustrate this is with a number line. Now just like we did the other day with inequalities, we're going to mark our points of interest. In this case, 2 is very important because of the first part, and 10 is also important because of the second part. So if I was just to look at the first statement here, where are the numbers that are bigger than 2? Well, that's everybody starting with 2, open circle, because we don't want it equal to 2, going this way to the right. Okay, inside here is 3 and 4, 3 and 4, 5, 6, 7, 8, 9, 10, and in fact 11 and 12 and 13, everybody over this way is bigger than 2. But at the same time, while the numbers we want are bigger than 2, they also have to be less than 10. And those start at 10 but they go this way. Remember, we talked about the fact that if you point or leave your x on the left-hand side, the inequality shows which way to point your arrow. Okay, in this case, I want to point to the left because that's my numbers that are less than 10. Because it is an AND statement, and I have to satisfy both those conditions, as I draw this line going to the right, and I draw the other line going to the left, the AND part, or the numbers that are both greater than 2 and less than 10, are those just trapped in between that 2 and 10. So you can see where they overlap. That's where AND statements take hold. So my final answer, and I've kind of cluttered up my number line, so I'll show you how the final answer should look when you graph it. It looks like this. And that illustrates in this graph that everybody between 2 and 10 makes both of these statements up here, greater than 2 and less than 10, true at the same time. And so every number in there is a solution to this AND statement. Now to write your solution for this, because this is how we show it on the number line, but actually to write the statement, we write it this way. I want x's that are greater than 2 and less than 10. Note I don't have to put AND in my final statement. This is a shortcut method to write the AND statements, but it does illustrate that x's are everybody, and you always read from x's point of view, x's that are greater than 2, these guys, and at the same time x's that are less than 10. And so it traps us in between 2 and 10. Now let's look at this as an OR statement. Oops, there's the shortcut abbreviation again. Here's an OR statement. This is a different problem, but we'll see how typically these compound inequalities are written and then solved. So we've got two different statements here. X minus 2 is less than negative 8, or, so it's an OR statement, x over 8 is greater than 1. And all you have to do is what you did on yesterday's homework, which is solve that first inequality. Solve it just like you did. So we'll add 2 to both sides. In this case, to get that x alone, we find out that x has to be less than negative 6. So we solve the left-hand part of this compound inequality. We're going to keep track of that OR, so always write that as you're working. The next statement, we got x divided by 8 is greater than 1. We can't simplify each side, we just have to get x alone. Well, it's x divided by 8, so to undo division, we will use multiplication. We can see the 8's cancel, giving us x is greater than 1 times 8. And now your best step is to understand what's going on and, as part of your answer, to draw a graph. Mark your key points. Negative 6 is the small number and 8 is the big number. We want x's that are less than negative 6. That's everybody to the left of it. And x's that are greater than 8. That means everybody to the right of 8, 9, 10, 11, 12, those big numbers. That's what our graph looks like. And our final solution is exactly what we've written right up here. So when you write your answer, you're going to show the graph, and you will show your AND or OR statement. Now there's no abbreviation for OR statements. Every time you have an OR statement, you will be writing the word OR. If you do not put the OR in there, we don't know if it's an AND or if it is an OR, so it would not be correct. Let's look at another example. Note this one does not say AND, it does not say OR. Also notice it does have two inequalities. So when you see two inequalities in a statement like this, you know it's a compound statement. It does not say OR, so it must be an AND statement. To solve a problem like this, you simply have to break it up into two separate statements connected with an and. Now notice the middle part. And so we're going to extract this into two different inequality statements. Here's the first one. -1 is less than the middle stuff, 9 plus x, and the middle stuff, so we just repeat that middle again, has to be less than 17. So you can see how we've pulled that out of it and written our two inequalities. Now you solve both those. In the case of the statement here on the left, I want to get that x alone. It's 9 plus x, so I'm going to subtract that 9. So minus 9 minus 9. And I get -10 is less than x. Now again, I usually don't like expressions written this way. I prefer x is greater than 10 and flip-flop that. But you're going to find it helpful actually as we write our final statement to be able to understand how this is the same thing as x is greater than -10. On the right hand side, I've got 9 plus x. I got to get rid of that 9, so I'm going to subtract it. And I get x is less than 17 minus 9 is 8. So let's take a look at the graph of this so we can kind of understand. Here's our smallest number, -10. And again, if you read from x's point of view, you want x's that are bigger than -10. Now if you were to flip-flop this so the x's on the left-hand side, again, that's helpful because with x on the left, you can see which way the inequality points, and it shows you want x's that go to the right in this direction. The other statement, we've got 8, and we want x values that are less than 8. And so those go in this direction. And you can see how these two arrows are going to overlap as they cross each other. And see, it's that overlapping region that contains all of the answers. Because the numbers in here, for example, there's the number 0 is between them, and 0 is both greater than -10, and at the same time it is less than 8, so it's making both statements true at the same time. And in fact, every number in this region makes both those statements true. So look at how we write our answer for this. To write your answer now, because it's an and statement, all you have to do is write the variable x, point both inequalities to the left, and from x's point of view, it'll say x is less than 8, and x is greater than -10. So we have our complete solution. We've shown the graph, and we've written the notation that's appropriate to indicate what x is that makes this compound inequality true. Let's try another one of these. Okay, we can see we have an or statement. Or statements will always use the word or. It's not like and statements where we have a shortcut method to write them. And again, all you have to do is solve these two inequalities separately. So let's work on this one on the left-hand side. We'll add 5 to both sides, giving us 7x is greater than or equal to 70. We'll divide by 7. X is greater than or equal to 10. That's the first part of our problem. The second part, another inequality, we just solve that. We'll add 2 to both sides. Giving us -3x is greater than or equal to 0. We'll divide by -3. Now note here, I divided by a negative, and when you divide by a negative, do not forget, you've got to flip that inequality. So it was a greater than symbol, and now it became a less than symbol because I divided by -3. Excuse me. Now remember, this is an or statement, okay, so keep track of that. Let's take a look at the graph. 0 is our small number and 10 is the big number. I want x's, numbers that are greater than 10. That's these. And then I want numbers that are less than or equal to 0. I should have filled in my circles because of the equal sign. So this graph tells us that anybody less than 0 makes this statement at the very top true. It doesn't satisfy both of them, but it doesn't have to. It just has to either satisfy the inequality on the left or the inequality on the right. If you're less than 0, you make this one true. And if you're greater than 10 or equal to 10, you make this one true. So all these numbers, negative 1, negative 2, negative 3, those all work as solutions. 11, 11.5, 12, and 13, and so on, make the other side true. When we write our inequality statement at the very end, all we have to do is go x is less than or equal to 0, or x is greater than or equal to 10. And so our final solution would be the graph, along with the mathematical or statement. Last example. Again, kind of looks complicated, but you can see we've got two inequalities. That means it's a compound inequality. We decide if it's and or. Since it doesn't say or, it is by default an and statement. We break it up into two different groups. Negative 50 is less than 7x plus 6, and at the same time, repeating the middle section, 7x plus 6 is less than negative 8. We solve each of those. I'm going to subtract 6. Negative 56 is less than 7x, and divide by 7. Dividing by a positive, so I do not flip my inequality. So the left-hand side of this and statement says x is greater than negative 8. On the right-hand side, we subtract our 6. 7x is less than negative 14. And we divide by a positive 7, so we don't have to flip anything. Negative 14 divided by 7 is negative 2. We graph it. Negative 8 is the small number. Negative 2 is the bigger number. Read from x's point of view. X has to be bigger than negative 8. That means I'm looking at numbers to the right of negative 8 where they are bigger. X is less than negative 2. So I'm looking for numbers that are smaller than negative 2. And because it's an and statement, I want this overlapped section in the middle. That's where all the numbers exist that are both greater than negative 8 and less than negative 2. And then I just write my inequality. Just put down your x, point your arrows to the left, negative 2, negative 8. And that's our abbreviation for how to write that and solution set. Alright, you don't have a huge number of problems on today's homework. Certainly you're going to want to try those, take a shot at your graphs, and come back with questions tomorrow.